this video, we'll be using methods of Lagrange multipliers in order to solve for distance, or minimize and maximize distance. So, for the first problem, I'm not writing number 1, but for the first problem, we are going to minimize the distance between a plane defined by 2x plus 3y plus z is equal to 3. So this is a formula of a plane, and we're going to find the point on this plane that is closest to this point in space. So let's go ahead and begin. And just keep in mind, this point is not on top of the plane. This point was on the plane, the distance would be 0 between this. But we're trying to find the distance between the plane and this point. The minimized distance between the plane and this point. And by doing so, we will find the point on this plane that is closest to this point in space. Let's begin. Okay, so first off, we need to define a actual function. We have our constraint, and our constraint is this right here. So our constraint is just the plane function, but we don't have a point. I mean a formula, a function for the distance. So the function for this distance will be defined as the square root of x minus 1 plus y minus 2 squared plus z minus 1 squared. And if you just like look at the abstracts of this, this distance formula makes sense, and that's because this is just a distance formula for any point x, y, z. Not the point, any point on this plane, but just any point in space, x, y, z. So you just pick a random point in space, and then that point will be x, y, z here. But in order to find the distance between that point, you need to subtract by the values of this point. So these corresponding values, minus 1, minus 2, and minus 1. Notice how that's the same order of these points. And you square it, and you square root that entire thing. This is just the Pythagorean theorem in order to solve for the distance between it. Now, let's make this even simpler. And to be honest, you don't even have to understand this. Here, I just write down a quick general formula for you guys to just understand. The quick general formula is just x minus x null squared plus y minus y null squared plus z minus z null squared. So this is just a quick formula that you can use. Notice how this is the exact same thing as this, except I just plugged in null values. And this all equals distance, by the way. So just use that general formula if you want. But honestly, you don't even need to use that general formula because you can just create this distance formula by yourself. But let's simplify this. You can actually simplify this further by doing this, by squaring both sides. Now, why can you find distance squared? Well, you're trying to minimize distance, but you can actually use distance squared. Why is that? Well, because when you minimize distance, it's the same thing as minimizing distance squared. Both of these are monotonically increasing. Maybe you remember that word in your calculus 2 class. But both of these distances functions will increase as long as the other side of the equation increases. That's why you can use distance squared, because if you minimize distance squared, you minimize distance as well. Okay, let's keep going. So now that we have our actual function, this will be defined as our f function in this case, and just remember that this is distance squared. This will be defined as our f function. And this 2x, so 2x plus 3y minus plus z minus 6 is equal to our g function. So this is our constraint, our g function, and our main function is f. What do you have to do in order to solve for this using methods of Lagrange multipliers? You need to find each of the gradients. So the gradient of f is just 2, so just 2x minus 2. The gradient of the y partial is 2y minus 4, and the gradient for z is 2z minus 2. And notice how I just used power rule. I brought down the 2, and I distributed the 2 along in these parentheses. So the gradient for g now is 2, 3, and 1. Now that we have these, what can we do? Well, we can pair up each corresponding component. Very bad circles, they don't measure anything. But if you pair these up, you can set them equal to each other. 2y minus 4 is equal to 3, and 2z minus 2 is equal to 1. But remember, we have to put a lambda in here to use methods of Lagrange multipliers. So once we put in the lambdas on the easier side, so I remember, if you watched my method of Lagrange multiplier videos, I always put the lambda on the side that's easier. So, and like the general formula that you'll see in textbooks is probably gradient of f times lambda of the gradient of g, but it doesn't matter which side you put the lambda on. Whichever one's easier to do the algebra is what I prefer. The math will all be the same. You'll get the same answer in the end. So if I just simplify this, well, we have 3 components, correct? We have 3 of these functions. Technically, we actually have 4 because of our constraint. Plus z is equal to 6. You can do minus 6 is equal to 0, but I'm just do equal 6 for now. And now that we have all of our formulas, what do? Now we have our methods of Lagrange multiplier set up. From now on, it's just algebra. And what I prefer to do is to isolate my variables. Whenever you have a 3-component Lagrange multipliers to solve for, what I mean by 3 components, just the everything but the constraint, right? Redo that. I like doing this by isolating the variables. So I'm going to isolate x, y, and z, and then substitute my lambda back into here. So when you isolate x, y, and z, this is what you get. Put this over some brackets. So when you isolate the x, y, and z, you get, let's just do this step by step. 2x minus 1 is equal to lambda, because I divided by 2 on both sides. What else is there? This is, yikes, this is annoying to do. This is 2 over, y minus 2 is equal to 3 over 2 lambda, and z minus 1 is equal to, what is this? Divided by 2, lambda over 2. Then once you do this, you can isolate the variables by just turning x is equal to lambda plus 1, y is equal to 3 over 2 lambda plus 2, and z is equal to lambda over 2 plus 1. Now that we isolate our variables, we can actually substitute them into our constraint. Let's go ahead and do that. We're substituting x, which is just lambda plus 1. Substitute y now, which is 3 over 2 lambda plus 2. And we're substituting in z now, which is just lambda over 2 plus 1. It's equal to 6. Let's just expand everything and then combine our fractions to make this easier. So, or combine like terms. This is 2 times lambda plus 2 plus 9 over 2 lambda plus 6 plus lambda over 2 plus 1 is equal to 6. Now we saw for this, we just have to combine like terms. This turns out to be 5, so this turns out to be 7 lambda plus 9 is equal to 6. And if we just solve for lambda, you get, so this is 7 lambda is equal to negative 3. Therefore, lambda equals negative 3 over 7. Now this is an important thing that we actually have to use, because once you solve for lambda here, you can actually just plug our lambdas back into this function here, and you can solve for our individual x, y, and z functions. That's what I like about isolating our variables and solving for lambda. And easy part, just plugging back lambda into here. Let's go ahead and do that. And let's make this part smaller so we have more space to do that for. So if we plug in lambda back into these functions, x is equal to negative 3 over 7 plus 1. Y is equal to negative 3 over 2 times negative 3 over 7 plus 2. And z is equal to negative 3 over 7 divided by 2, which is just 3 over 14 plus 1. And if I just solve for all of this, I mean, like, you can honestly just leave it at this. This is a constant, but for you guys, I'll just solve for the rest of this. Let's draw an arrow to show that we're taking steps. So x is just equal to, this is 7, so this is 4 over 7. Y is equal to, this is negative 9 over 14. So negative 9 over 14 plus 2 is equal to 9 plus 28 is positive 19 over 14. And z is equal to, I ran out of space at the bottom, so I'll just write z here. Z is equal to 11 over 14. There you go. This is the point on the plane. This right here is actually our answer. But this is the point on the plane where the distance, well, technically distance squared, but the same thing as distance, is minimized. And if you were to plug these points back into here, into this constraint, you would be able to get the right answer. For the next problem, our function, so our plane actually, will be defined by 3x minus 4y plus 5z is equal to 10. We're trying to minimize the distance from the point to negative 1 and 3. So let's begin. Let's go first off, start with our distance formula. So our distance formula is x minus x null, which is 2 squared, plus y minus y null, which is just plus 1, plus z minus z null squared, all square rooted. So this is our distance. But remember, we can solve for distance squared as well, because distance squared can still be minimized or maximized. And remember, distance, due to the fact that it's monotonically increasing, if we minimize distance squared, we've also minimized the distance. The reason why we're doing that is because we're going to remove a square root here. So you want to get rid of the square root because the square root is very, very annoying to deal with when you're dealing with integrals or derivatives. So you might as well make the problem easier by solving for distance squared. Once you have that, this is our function. So this is our f of x, y, z. And this is our constraint here, the plane. Minus 4y plus 5z minus 10 is equal to our constraint. We have to find the gradients so that we can use our Lagrange multipliers for this. So the gradient is minus 4 for our x partial. Our y partial gradient is 2y plus 2, and our z partial gradient is 2z minus 6. Our g gradient is 3, negative 4, and 5. So all we have to do is now set up this Lagrange systems of equations. So we have 2x minus 4 is equal to 3 lambda. 2y plus 2 is equal to negative 4 lambda. And 2z minus 6 is equal to 5 lambda. And don't forget about our constraint in this system. Okay, we can erase everything else now. And now all we have to do is solve for this systems of Lagrange multipliers. So let's start it off by just isolating this section here. And we can simplify this part further by isolating x, y, and z and making x, y, and z a function of lambda. So if we isolate x, y, and z slowly, we get x minus 2 is equal to 3 over 2 lambda. Y plus 1 is equal to negative 4 over 2, which is just negative 2 lambda. And z minus 3 is equal to 5 over 2 lambda. Simplify this even further. Not simplify this, just isolate x even more, or isolate our variables even more, and then you get this. Y is equal to negative 2 lambda minus 1, and z is equal to 5 over 2 lambda plus 3. Now that we have this, we can substitute these functions in to our constraint. So let's do that. Almost forgot to erase that. So you get 3 times 3 over 2 lambda plus 2 minus 4 times negative 2 lambda. Oh, no need for that. Negative 2 lambda minus 1 plus 5 times 5 over 2 lambda plus 3 is equal to 10. Now if we just expand or distribute everything, we get 9 over 2 lambda plus 6 plus 4 plus 8 lambda plus 4 plus 25 over 2 lambda plus 15 is equal to 10. Just put everything together and then you get, this is 34, so this is 17 plus 8 is, so we combine like terms, we get 25 lambda plus 10, 25 is equal to 10. If you simplify this even further, you get 25, you actually can factor out, this will probably make it easier. Factor out of 25 equals to 10, and then you divide 25 by both sides, you get lambda plus 1 is equal to 10 over 25, which is just equal to 2 over 5. Simplify this further, subtract by 1, you get lambda is equal to negative 3 over 5. So now that we have lambda isolated, we can plug lambda into each of these x, y, z values. So x is equal to 3 over, let's make this smaller, x is equal to 3 over 2 times negative 3 over 5 plus 2. Y is equal to negative 2 times negative 3 over 5 minus 1. And z is equal to 5 over 2 times negative 3 over 5 plus 3. And I made a quick mistake here. This should be plus 1 outside of the parentheses. Minus 1. And then once you just expand everything, you get x is equal to negative 9 over 10 plus 2. Y is equal to 6 over 5 minus 1. And z is equal to negative 15 over 10 plus 3. So these are just your answers. I could just simplify this further for you guys, actually. But that's not necessary. Honestly, once you get constants, you already have your answer. But this would be equal to 11 over 10. Y would be equal to 1 over 5. And z would be equal to, this is, hold up, 15 over over 2. So if you have any questions, put it down in the comment section.